The Labrador Sea is a vast expanse of cold blue water, stretching out as far as the eye can see. It lies between Greenland and Canada, two regions known for their rugged and icy landscapes. This sea is not just an ordinary body of water, it is a dynamic and vital part of our planet's ecosystem. It plays a crucial role in the Earth's climate system, influencing weather patterns and ocean currents. The Labrador Sea is also home to a rich diversity of marine life, from tiny plankton to large marine mammals like dolphins and seals. The Labrador Sea is named after the Labrador Peninsula, a region known for its stunning natural beauty. This peninsula forms part of Canada's eastern coastline, characterized by its rugged and dramatic landscapes. Greenland, the world's largest island, lies to the east of the sea, with its coastline dotted with majestic icebergs. This location makes the Labrador Sea a gateway between the Arctic Ocean and the Atlantic Ocean, facilitating the movement of water and marine species. The Labrador Sea is quite deep, with its waters plunging to significant depths. Its average depth is about 2,000 meters, making it a profound and mysterious part of the ocean. That is deeper than most swimming pools, which are typically only a few meters deep. The deepest point plunges down to around 3,400 meters, creating underwater canyons and trenches. This depth contributes to the unique characteristics of the Labrador Sea, influencing its temperature and marine habitats. The Labrador Sea is a vital part of the North Atlantic, playing a key role in the oceanic circulation. It connects to other important bodies of water, creating a network of marine pathways. These include Baffin Bay and the Davis Strait, both crucial for the movement of water and marine life. It also connects to the Atlantic Ocean through the Flemish Pass, a significant underwater channel. These connections allow for the exchange of water and marine life, making the Labrador Sea a dynamic and interconnected part of the world's oceans. The Labrador Sea is a place of dramatic contrasts. Towering icebergs drift southward from the Arctic. These icy giants paint the sea with brilliant white and blue hues. The Labrador Peninsula and Greenland frame the sea with rugged coastlines. The Labrador Peninsula is a vast and wild region. It is known for its rocky shores, dense forests and sparkling lakes. The peninsula is home to a variety of wildlife. Polar bears, caribou and wolves roam its interior. Greenland, on the other hand, is a land sculpted by ice. A massive ice sheet covers most of the island. This ice sheet is a remnant of the last ice age. It holds within it a record of Earth's ancient climate. The coastline of the Labrador Sea is deeply indented. Fjords carved by glaciers long ago cut into the land. These fjords provide sheltered havens for marine life. They also offer breathtaking scenery for those fortunate enough to visit. The Labrador Sea is not a still body of water. It is alive with currents and movements that drive the global ocean circulation. One of the most important currents in the Labrador Sea is, unsurprisingly, the Labrador Current. The Labrador Current originates in the Arctic Ocean. It flows southward along the coasts of Newfoundland and Labrador, carrying cold, dense water. This current acts like a giant conveyor belt. It transports cold water from the Arctic to the tropics. As the Labrador Current flows southward, it interacts with warmer waters from the Gulf Stream. This mixing of water masses creates a dynamic and productive environment. It also contributes to the formation of dense water that sinks to the depths. The sinking of cold, dense water in the Labrador Sea is a crucial process. It helps to drive the global thermohaline circulation. This circulation pattern, often referred to as the ocean conveyor belt, distributes heat around the planet. It plays a vital role in regulating Earth's climate. Despite its cold temperatures, the Labrador Sea teems with life. It supports a rich ecosystem that is vital to the health of the North Atlantic. The sea's productivity is fueled by a process called upwelling. Upwelling occurs when winds push surface waters away from the coast. This allows deeper, nutrient-rich waters to rise to the surface. These nutrients provide a feast for phytoplankton, the tiny plants that form the base of the marine food web. The abundance of phytoplankton in the Labrador Sea supports a diverse array of marine life. Zooplankton, small animals that feed on phytoplankton, thrive in these waters. They, in turn, become food for larger creatures. Fish, such as cod, halibut and herring, are attracted to the Labrador Sea's rich feeding grounds. These fish are an important food source for marine mammals, seabirds and humans. The Labrador Sea is a vital fishing ground for both commercial and indigenous communities. The Labrador Sea is not immune to the impacts of climate change. In fact, this region is experiencing some of the most rapid warming on Earth. The effects of this warming are already being felt throughout the ecosystem. One of the most visible signs of change is the shrinking of the Arctic sea ice. As sea ice melts, it releases fresh water into the Labrador Sea. This fresh water is less dense than salt water. It can disrupt the formation of deep cold water that drives ocean circulation. The warming waters of the Labrador Sea are also affecting marine life. Some species, such as cod, are shifting their distributions northward in search of colder waters. Other species, such as shrimp, are experiencing population declines. The changing conditions in the Labrador Sea are a cause for concern. Scientists are closely monitoring these changes to better understand their potential impacts. The health of the Labrador Sea is intimately linked to the health of the planet. Section 6. The Labrador Sea's influence on weather. The Labrador Sea doesn't just influence ocean currents, it has a profound impact on the weather systems that affect millions of people. It also plays a significant role in shaping weather patterns across the North Atlantic region, affecting everything from daily weather to seasonal climate trends. This influence is particularly noticeable during the winter months when the sea's interactions with the atmosphere are most dynamic. During winter, the Labrador Sea releases a tremendous amount of heat into the atmosphere, which can significantly alter weather patterns. This heat transfer is driven by the large temperature difference between the cold air and the relatively warmer sea surface, creating a dynamic environment. This heat release can fuel intense storms, making them more powerful and longer-lasting. The Labrador Sea also influences a major climate pattern known as the North Atlantic Oscillation, or NAO, which has far-reaching effects. The NAO is a seesaw in atmospheric pressure between the Icelandic low and the Azores high, and it plays a crucial role in determining winter weather. When the pressure difference between these two systems is large, which is known as a positive NAO, winters in eastern North America and Western Europe tend to be milder and wetter, often bringing more rain and less snow. When the pressure difference is small, known as a negative NAO, winters are often colder and drier, leading to harsher conditions and more snowfall. The Labrador Sea's role in these weather and climate patterns highlights its far-reaching influence, extending well beyond its immediate vicinity. Changes in the Labrador Sea, such as warming waters or altered ice cover, can have ripple effects across the entire North Atlantic region, influencing weather patterns and climate conditions far and wide. Section 7. Riches from the deep. The Labrador Sea is not only a place of ecological significance, it is also a region of economic importance. The sea's rich natural resources have supported human activities for centuries. Fishing is a vital industry in the Labrador Sea. For generations, fishermen have relied on these waters for their livelihoods. Cod, shrimp, and halibut are among the most important commercial species. However, overfishing in the past has led to declines in some fish stocks. In recent years, there has been growing interest in the potential for oil and gas exploration in the Labrador Sea. The seabed beneath these waters may hold significant reserves of hydrocarbons. However, the development of these resources is not without controversy. The potential environmental impacts of oil and gas exploration in the Labrador Sea are a major concern. Oil spills, noise pollution, and habitat disruption could have devastating consequences for marine life. The potential economic benefits of resource extraction must be carefully weighed against the potential environmental costs. Section 8. The future of the Labrador Sea. The Labrador Sea, like many parts of the ocean, is facing a number of significant challenges. Climate change, pollution, and overfishing all threaten the delicate balance of this vital ecosystem. Rising temperatures are altering marine habitats, while pollutants from various sources are degrading water quality. The future of the Labrador Sea depends on our actions today. Community efforts, such as cleanup events and conservation initiatives, play a crucial role in safeguarding this precious environment. Reducing greenhouse gas emissions is essential to mitigate the impacts of climate change. Investing in renewable energy sources like wind and solar power can significantly reduce our carbon footprint. International cooperation is crucial to achieve this goal. Countries must work together to set and meet ambitious climate targets. Transitioning to cleaner sources of energy, improving energy efficiency, and promoting sustainable practices are all part of the solution. These efforts can help reduce the strain on the Labrador Sea and other marine environments. Protecting the Labrador Sea's marine life requires sustainable fishing practices. Fishermen must adopt eco-friendly methods to ensure the long-term viability of fish populations. Setting catch limits, reducing bycatch and establishing marine protected areas can help to ensure the long-term health of fish stocks and the ecosystem as a whole. These measures are vital for maintaining biodiversity. Addressing pollution from land-based sources is also critical. Industrial runoff and urban waste can have devastating effects on marine ecosystems. Runoff from agriculture, industry and urban areas can carry pollutants into the Labrador Sea, harming marine life and degrading water quality. Effective management of these pollutants is essential. Implementing better waste management practices and reducing our reliance on harmful chemicals can help to protect the marine environment. By making these changes, we can ensure a healthier future for the Labrador Sea and its diverse inhabitants. Section 9. A call to action. The Labrador Sea is a remote and often overlooked part of our planet, yet its influence is felt far and wide. The health of this sea is intimately connected to the health of our planet and the well-being of future generations. We have a responsibility to protect this vital ecosystem. By understanding the challenges facing the Labrador Sea, we can make informed decisions that will ensure its health for generations to come. The time to act is now. Support sustainable fishing practices. Reduce your carbon footprint. Advocate for policies that protect our oceans. Together, we can make a difference. The future of the Labrador Sea and our planet depends on it.